Today we'll be looking at applications of quadratics, and yes, there is some. So when completing applications questions, just follow these steps. First of all, define the variable, so let x equal whatever it is. Write an equation and solve it. And also this last one here, just check that the solutions are reasonable, and often that'll be dictated by the context of the problem. So draw the diagram, label it, and check your solutions to see whether it is appropriate. So let's just try some. Here is the classic quadratics problem. So the area of a rectangle is 144 centimeters squared. If the length is 7 centimeters more than its width, what is the perimeter of the rectangle? So we'll say let x equal the width. Right, let's draw our rectangle. And here is the length is x plus 7. Here is the width, it is x. So x is the width, and the length is 7 more than its width. So the area of the rectangle is 144 centimeters. What is the perimeter? Okay, so what we'll say is area equals length times width. The area is 144 equals x multiplied by x plus 7. Alright, so we need to solve this thing. Now recall that to solve this, what we need to do is use the null factor law. So let's get x squared plus 7x, take away 144, equals 0. Alright, so for this one here, what we'll do is, let's use our calculator for this one. So we'll go a shift and equals 144 equals x plus 7 comma x. Actually that could have been solved via the cross method, so we could have factorized that quite easily. So x, and that would have been a 16 times 9. 90, 96 to 54, yeah, that would have been a 16 times 9. The reason why I didn't pick that up is I'm not so familiar with my 16 times tables, I'm afraid. And what we needed is one of them needs to be negative, and it's going to be this one. So let's go 0 equals x plus 16, x take 9, x equals 9, x equals negative 16. Alright, now what we'll do is we'll just check our two solutions. So in the context of the problem, we'll note that x has to be greater than 0 to have a width. So x can't be negative 16. So we say something like this, but x equals 9 only as x greater than 0. i.e. what we're going to do is essentially reject the negative solution because it's not appropriate for the context of this problem. Alright, next one. The product of two consecutive even numbers is 120. Form an equation and solve it to find the numbers. Okay, so let x equal the first even number. So the product of two consecutive even numbers. So the first consecutive even number we'll say is x. The second one is going to be 2 added on to that number, and that's going to be 120. Alright, so we'll go about this one the same way. X squared plus 2x take away 120 equals 0. 12, 10, okay, I can do this one. X, 12 and 10 is 120. That needs to be negative. X take 10, x plus 12 equals 0. X equals 10, x equals negative 12. Alright, so what's our answers here? So form an equation and solve it to find the numbers. Okay, so a possible one is 10 and 12. Okay, so x is the first even number. The second even number is x plus 2, so that's 10 and 12. So that's one possible configuration. Now, is this an appropriate solution? This is negative 12. The next even number is negative 12 plus 2, which is negative 10. So they are consecutive. They are after each other, or two consecutive even numbers anyway, and they multiply together equal 120. So that is appropriate, and that is appropriate. So we don't need to reject a solution here. It doesn't say the product of two even consecutive positive numbers. So yeah, both of those solutions are absolutely fine for this one. Okay, this time around we've got a rectangular garden of length 12 meters by 8 meters is surrounded by a grass path. So there's our rectangular garden, and here is our grass path. Noting that I've just looked ahead, the grass path has the same width around the entire garden. What is the width of the path if the total area of the garden and path is 192 meters squared? So we get a length of 12 by 8. Alright, now the total area of the garden and path, so this multiplied by this equals 192 meters squared. So what is this length here? Well, that's going to be x take away, let's not do that. Okay, so you can see, again, I'll probably leave that part in the video there because just having a bit of a guess at this. What I'm going to say is this length here is going to be x, and this length here, because the garden path has the same width around the entire garden, that's also going to be x. So this whole length here is going to be 12 plus 2x. Okay, so this 12 here plus the x plus the x. Now this dimension here is going to be 8 plus this width here, which is x, and this width here, which is x, which I know is x because it's the same width around the entire garden. So this one here will be 8 plus 2x. Alright, so what is the width of the grass path if the total area of the garden and path is going to be 192? Okay, so what we need to do is we need to solve this thing for x. Okay, so what we're going to do is say that 12 plus 2x, 8 plus 2x, multiplied together, that by that is equal to 192. Right, so how do we solve this thing here? Well, it's untidy. We're going to have to expand this out first of all. So it's going to be 8 times 12 is going to be 80, 96. Then we've got 24x. We've got 16x. And we've got 4x squared is 192. Okay, so now we've got 4x squared, them together is 40x, so 16 and 24 is 34 is 40. Okay, now 192 removed from 96 is going to be negative 96, I think. 96, take away 192. Yep. Alrighty, so then what will make this a little easier is if I factorize the 4 out, or pull the 4 out. So let's go 4x squared plus 10x, 96 and 4, 2, 1, 4. Probably should have known that one. Okay, now what I'm going to do is divide both sides by 4, leaves me with x squared plus 10x, take away 24, leaving me with something considerably easier to factorize than this one here. So this is going to be 12 and 2, I think, x. So 12 and 2 is 24, one of them has to be negative, and it's going to be that one. Okay, so it's going to be x plus 12, x take 2 is equal to 0. Drop the equal 0 there, whoops. x equals 2 and x equals negative 12 via the null factor law. Okay, so now we've got to think about which one, if are they both appropriate. So x could equal 2, that's appropriate. X can't equal negative 12. Okay, so we're going to say that x equals 2, cannot equal negative 12 as x needs to be greater than 0. So again, I've just showed that I've rejected this negative 12 solution here. The reason is x is greater than 0. You could get into a whole story about lengths can't be negative, blah, 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 but it's fine to just say, hey, I'm rejecting it because x has to be larger than 0. That's good enough for solution rejection. Okay, this last problem is a tricky one, I should know, because I just had to re-record this part of the video because I stuffed it up the first time. So let's have a go. Bill knows that when he takes the square root of his favourite number after 6 has been added to it, it is the same as the difference between the number and 6. Okay, so let's go for it. Let x equal Bill's fave number. So what happens is he takes the square root of it after 6 has been added to it. And it's the same as, it's equal to the difference between the number and 6. Alright, solve an equation to find Bill's number if Bill's number is even. Okay. Alright, so let's go for it. So what I'm going to do here is I need to get x by itself. It's currently being square rooted on this left hand side. So I'll just square both sides. So I've got x plus 6 equals x take 6 all squared. X plus 6 equals x squared. Take away 12x plus 36. 0 equals x squared. Take 13x plus 30. Now here's where I stuffed the video previously. I factorized it incorrectly. I used 15 and 2. It's 10 and 3. So both of them are going to be negative. 0 equals x take 10, x take 3, x equals 10, x equals 3. Alright, so we've got two solutions here for Bill's number, but x equals 10 as x is even. Okay, so we're going to reject this one here, even though it does make sense. 3, well, it doesn't actually make sense. So 3 plus 6 is equal to 9. 9 square rooted is 3. 3 subtract 6 is negative 3. So this doesn't even make sense in the context of the problem either. Now, this can happen when you're working with quadratics, and it can happen when you make the move of squaring both sides like this. What this does mathematically is it introduces what we call extraneous solutions. I won't really go into it, but the way to make sure that you don't include a solution that's inappropriate is you go back and, like the original advice was, you just check that your answers are reasonable by substitution or by looking at the context of the problem. Alrighty, so without further ado, you'll go ahead now and work through these problems here, noting that CAS would be appropriate for 9, 10 and 13, and then for some of your more tricky problems 14 and 15, both of them with CAS.